Okay, welcome back. We're going to be doing some... whatever our next movement is, right? So our movement event, we've got up through movement event 3, which means we can select our first movement grid. But we're actually not done with this yet. So actually the first thing we're going to do is fix our rendering for all of our legal moves. Now right now, we're rendering anything as legal move true with a bright green highlight, but if we lock in our stones, you'll see that we're highlighting every stone regardless of the mouse position. So we need to only toggle the legal move highlight to be true if our mouse position is over it and it's a legal move. Otherwise, legal move highlight is false. So once we do that, then we need to lock in our first movement grid. Because yeah, movement event 3 is to select our first movement grid. So movement event 3 happens when we hit enter to lock in the amount of stones we have. So yeah, to finalize movement event 3, we need to not only fix the rendering, but then to allow, if a mouse click on a legal move, then we actually lock in our first movement grid, which also should lock in our direction of movement, either down, up, left, or right. So let's see if we can't figure that out. Where do we start? We would start with, we're populating our legal moves, and then we're falsifying them if they're a capstone or standing stone. Now our movement origin stays rendered as a bright green, but what we do need to do is to flush any move that flush the highlight of any move if our mouse is not over that position. So on a movement event 3 here, okay, I'm glad we left that note there because that's what caused the bug yesterday, but we'll just have to remove this end so that this can be an else if, and then we can continue this logic. We just need to add another end to the bottom. So what I'm going to do here is say, I think we need a nested for loop, but we've already got a nested for loop right above it. So not only do we check for, actually, yeah, we do need to flush this. I don't know why that was turned off. Let me check to see if we'll render that. If there's a capstone or standing stone orthogonally, we'll put both and see. Okay, cool. So yeah, so like since there's a standing stone and a capstone in these orthogonal spots, it's rendering it as a legal move false, which should be true. Well, no. That's correct that it's legal move false there, if it's a capstone or standing stone. So that's working. So what we're also going to do in this nested for loop is say if our mouse grid is equal to I and our mouse grid x is equal to j, meaning that when we ask this question, or when we populate this thing, and we can actually just put ij here. So what this is saying if our mouse grid is the same as this grid that we're typing, then we need to say something like, now the legal move highlight is in the occupant class. Yes. So legal move highlight, we actually want, okay, we had this move locked highlight for the darker green. We're not there yet. So it's this legal move highlight on our occupant class. So our dot legal move highlight is the thing we're trying to switch here. And we're trying to switch it based on if our mouse grid is equal to the for loop, This is just giving us a way to access the grid of which our mouse is over. So we need to say, hey, if this grid is a legal move, then sure, let's put that occupant's dot legal move highlight dot dot dot. Let's set that legal move highlight to true. But here's where the magic happens. We say else, which means if our current mouse is not over a legal move, then we actually flush that to false regardless of legal move status. But it doesn't flush legal move status, so if we move our mouse back over it, we'll be able to highlight again. So let's see if that works for us. Come on. Okay. So we added, we added this, maybe 6 lines here, 5 lines. Let's see if that fixes our render issue. Let's put a standing stone just for fun. It is not working. So there's somewhere where we're actually flushing our legal move highlight to become true, which is, oh dude, wait. This is it. This is an older one that we're trying to basically do the same thing. movementEvent 3, legal move. See, so we shouldn't be doing, oh, look at this. Oh, that's something else. Okay. I guess I'm a little confused why this isn't working. Legal move highlight gets true. Let's do, this should be working, man. Because this is falsifying correctly. So this should be working. But our legal move highlight, if we search that, I just want to see any position where we actually turn that true, where it wouldn't be the case. Now we're turning it true if basically this is just saying turn our legal move highlight at the origin, movement origin place to be true. And then we have, that's the only other spot we do that. Okay. See, and this is in movementEvent 1, so that shouldn't affect our current code. So what are we doing wrong here? If we take a look at what we're doing in movement 1, we're doing that nested for loop, and then we're saying if mouse grid O is equal to Y. Are we doing that? Yeah, we are. And equal to J, then if it's a legal move, then sure, highlight it true, otherwise highlight it false. Now, what do we, if we do this, no, let me just test something. So, out of here, we're just gonna say every grid occupant will get wiped. Every render legal move. What is it? No, just legal move highlight. Legal move highlight gets true. False. We're trying to keep them a legal move, but not render the highlight just to see. With this, the move lock origin, the movement lock origin should still be light green. Let's see. Yeah, so that's still light green, but when we lock in stones, that becomes a legal move, except we're not rendering it. So how do we say If mouse y grid is equal to j or I, and mouse x grid is equal to j, then for right now I'm just going to say wherever our mouse is should turn that grid to be a legal move highlight, which should be able to work, but if it's not, it can help us debug into what's wrong. So we lock it in. See, like this. See how this is working? This is how I want the other ones to work. Now we're setting legal moves. So if it's a legal move true, it's rendering it, which isn't what we want. So where are we saying if it's true, render it? Does legal move highlight get set to true upon a legal move? I don't think so. See, because that's what I would expect to happen, but for all of them, not have the orthogonal ones stay lit up. So what's telling me? It's telling me that our legal moves are just rendering the legal move highlight if they are legal moves, which isn't necessarily the case. So I'm a little confused on what to do to fix that. Oh, dude, it's right here. If it's a legal move highlight gets true, else legal move false. So this is totally wrong. We don't want this. Why is there another end here? This is so weird. Oh, okay, that's just for the update function. So I don't think we need this, dude. I think that's been screwing us up here. Basically, what I kind of want to do is move this grid into that occupant update class so that we can say only render a legal move highlight on an occupant if it's a legal move. But that's also not really what we want to do, because that would only be applicable to this movement3 event, because we lock in our movement and then we don't have the player be able to highlight a legal move after that, because our direction gets locked in for us in this event. So I think I'm just going to take that out of our occupant class like we did. We already saved it. So now what should happen is what I was expecting it to be, which is our movement origins still has a bright green highlight. But the only other green highlight is going to be where our mouse is, and it should be on every grid other than that very middle one here. So we are able to turn it true. We just need it to be false if it's not. So if it's not over it. So we're going to say if our mouse grid is equal to that grid, if our mouse is over said grid, we're going to choose it. We're going to send it to legal move highlight, and if it's not over that grid, we're going to falsify it. So now that should work. So this should be what we are hoping for. Let's put a standing stone there just to test. And then once we lock it in, this shouldn't highlight because it's not a legal move. Nothing should highlight actually if we're not over it, but then this should highlight, this one should highlight, this one should highlight if our mouse is over it. So we lock it in. See, that shouldn't highlight. These ones are working fine though. We also need to ask if it's a legal move to highlight it or not. So if it's this and it's a legal move, and the grid at IJ, which is where our mouse is a legal move true, then we are actually going to modify that legal move highlight So now it shouldn't render that standing stone or a capstone. Once we hit enter, it doesn't render the highlight, but it does for these. No, it doesn't. I spoke too soon. What did we change? What did we break here? In a grid, J is a legal move. Let me see if we're actually legal moves. Yeah, we're a legal move. If we take this out, maybe we say down here if grid j dot legal move, then highlight that zone B. Otherwise, falsify it. Let's see if that works for us. Okay, we lock it in. Okay, now let's put a capstone on there and see. I should have just hit R to reset it, but okay, lock it in. Perfect. So now once we lock it in, we get all our legal moves are rendering true and they're highlighting appropriately, and nothing else is legal move, which is correct. So this is functioning appropriately for our movement 3. So this looks like it's the end of our movement 3. Now I'm kind of curious why this didn't work when it was up there, but I guess it's fine. I'm just gonna, falsifying legal moves, but then we also have legal moves, falsifying legal moves, and triggering highlights. Okay, so this isn't all we need for movement 3. We also need to detect a click upon a legal move. And if we click within a legal move, then we need to lock in our first movement row, first movement column, which is totally separate than our movement origin row, movement origin column. And hopefully that'll fix the bug we had to do to get rid of all of this code and refactor it because of this bug that I'm hoping to fix. Is because we were changing this move locked row, move locked column, depending on any given iteration with toggling with these freaking booleans like this. And that makes it very hard to test and debug. So now we changed it to that movement event so we can kind of keep track of our logic and our inputs for each stage of our movement turn. But now we need to add, I'm just gonna do, this is falsify legal moves, and this is legal move highlights. Now this is dangerous to put a quote here, because when we shrink this, all of this will get collapsed, and then if we're looking for legal move highlights, we might not be able to find it, but this is fine. So this is falsifying legal moves. So now we need click detection for a legal move, and then we need to lock in a movement row, first movement column. So do we have those variables? First of all, we have a first movement grid locked, first movement stones dropped. We have a dropped in first movement. But yeah, we need a first movement row, first movement row, first movement column. So where's our other column? Here, we've got move lock. No, that's not what I want. Where's our movement origin row? Here. I'm going to put it next to our movement origin row, just like this. So it's first movement row gets nil, first movement column gets nil. And then we also want to set these upon a player swap, not just the init. So on our player swap, we'll find our movement locks and also reset first movement. And then we need to do click detection, which looks a little bit like this. Love.mouse pressed. Now we don't need the X and a Y because we're actually asking the X and Y with our mouse grid, because the mouse position isn't really relevant to us. The grid that the mouse is over is relevant to us, which we're assigning earlier in our update. So we can just function. We can just worry about. We can pass in. I think we could do a 1 as the parameter here, and that'll equivalent to left mouse being pressed. We can test that. So we can say here in movementEvent 3, we're gonna also say the. Let's test this out and say if mouse is pressed at all, let's just stop rendering our grid 3.3, stop rendering our legal move highlight, which currently is true, but we'll set it to false upon a click detect, which I'm hoping that we can pass in this 1 here. Otherwise we'll have to do that button stuff, but I'm just kind of curious if this will work. Nope. Okay, it doesn't like that. It doesn't like... Maybe we say if instead of just a function. Will it let us do that? I mean... Come on, dude. What's going on? What are you doing? Okay, so far so good. Okay, so I'm gonna hit enter, and it should actually, yeah, lock in our highlights there. But now if I click with the left mouse, which I will now, I'm hoping that green will go away. And it doesn't. So maybe we do need the weird button stuff. I was hoping we didn't have to do that. I was hoping we didn't have to do this function thing here, but I think we do. So let's try the same thing, but with a function love mouse pressed with these parameters, and then we'll say if button equals 1, then we want to do this logic. Now, let's see. Okay. Still not working. And I think that's actually because we're doing this before we set this to true. So it could be working, so this was a bad test. So now I want to actually test. Let me comment this out for now, so we can remember to delete it if it's busted or whatever. But I'm kind of curious if after we set that legal move highlight, we say if love.mouse pressed is a 1, meaning we left click at all, then we're going to flush that to true. But even though, or flush it to false, but then since our movement origin row is locked, it'll set this back to true, and then it'll set it back to false every single frame, which this is just a test. I just want to see if this, I want to see if I can say love mouse pressed 1 and get rid of that whole function and X and Y and button stuff. That's what I'm hoping to determine from this. So we're in movement 3. Now if I click, it doesn't seem to do it. Okay. I guess I'll stop trying then. I think, what was it? Function love mouse pressed takes 3 arguments, 3 parameters. It is X, Y, and button. And then if our button is equal to 1, left mouse click, then we will go ahead and falsify that legal move. highlight, but for this test, we might as well falsify the legal move also, so it doesn't just keep rendering it true and flipping it back. Let's just see. Okay. Okay, this is... I want to say, we will also say, oh, this is... Oh, no, it isn't. We'll say, if movement event is 3. Movement event is 3, go ahead and try this. So it doesn't crash before our movement origin row is assigned, because that's what just happened. It crashed because it was nil. But let's see. Okay, I'm going to click. And it doesn't do it. Maybe this is a bad thing to try to test. Let's just try to do what we're trying to do. I thought it'd be really easy to just plug that in and have it work and then move on, but it's just not working for me. So under our movement event 3 logic, movement event is 3. We're going to be doing it right here. And we're going to say if the button is 1, why don't we go ahead. And the thing we're trying to do is detect a key press on a grid with a legal move. So if the mouse button is pressed and the grid we're on, which we need to do a nested for loop here. So if button is 1, then we got to do this nested for loop for I gets 1, 5, do for J gets 1, 5, do. I don't think I need these commas. And then we're gonna say if grid, no. Oh no, actually, yeah, if grid at IJ, if we click and the see, and we gotta do right here, we gotta say if mouse Y grid is I, which is our row, yes. If mouse Y grid is I and mouse X grid is J, then we're gonna set that grid. If it's a legal move, we're gonna say if that grid at IJ that we just clicked on is legal move true, then we are gonna lock in. We're gonna lock in our first movement row at I, and we're gonna lock in our first movement column from our J. So now that those are assigned, I'm just gonna say that movement event gets 4 so we can test if this line of code executes. Movement event gets 4. So if we click in a legal move mouse grid, we should get our first movement row column locked in and then switch movement events. So let's see if that's working. Nope. We missed this. Nice. That's exactly what I want. So we're movement event 4, and then we're rendering I guess I'm not really sure why we're rendering the highlights still on that, but it's looking to be working. So like what we need to do is flush this legal move because it's no longer a legal move once we click on it. So once we click on it and it was a valid move, then you're no longer valid. That might fix the rendering of the green, but we need to switch it to render the other color, the darker one. That's still rendering the busted one. I should have tested if it was legal move false or not, which let's see. Lock it in, click. It is a legal move false. So why are we rendering it? Huh. It's really weird to me. Why would... Oh, you know what? We're doing it right here under our click detection. In movement 3. Well, let me see. Yeah, in our move... Wait, where the frick is our movement 3? Movement 3. Oh, if we click in a legal move... I'm confused why our legal move highlight is true on that space once we lock in our movement event 4. Because our movement highlights, you know what? I think we just need to flush our legal move highlight here too. Because I think it's moving to 4 and it's leaving it turned on instead of looping the next frame and getting to this line to see that it's not a legal move anymore, so that it should be false. So I think we're just going to say that legal move highlight right here, right then and there gets false. Now, we could, I'm going to take out, we're not going to flush our legal move, we're just going to flush our legal move highlight, because we should probably falsify all legal moves from the get-go of our movement event 4 and then assign any legal move based on the movement direction. So we have to also lock in the movement direction for here, but let's see. I'm hoping that second square won't render green anymore. It should just be our movement origin. So once we click on it, yep, it disappears, but we don't want it to just not disappear. We actually want it to render our move locked highlight, which is a darker green. So we're actually going to say that. Now, for right now, I am going to actually explicitly set this as a no longer legal move, because it could mess up something. For the grid. Like, we just want all the data for the grids to be updated as we pass movement events. So just trying to keep that clean before we fix it. Click. Nice. Cool. So at this point, movement event 4 will be dropping stones in first movement origin, and then it'll be dropping stones in the next movement based on direction. But we need to lock in our direction. So how do we do that exactly? We need to compare our first movement row and column to our movement origin column in order to determine direction. So what we can do, so the idea is our movement origin row and column cannot be the same values as our first movement row and column. So all we do is compare those two variables, and I guess after we do the first movement assignment, after we do the mouse button press, Actually, upon mouse button press, we should set this, actually. So let's do this here. We get our first movement row and column. Then we're going to say if our movement origin row is smaller than, let me think this, because yeah, so it's based on the orthogonals. So if our movement origin row is smaller than our first movement row, that would mean that this is a downward movement lock, because higher row would be higher. So if movement origin row is smaller than our first movement row, then we know that our locked in direction is down. Is that right? If our movement origin row is smaller than our first movement row, meaning if our bright green box row is smaller than our dark green box row, then we know we have moved downwards. That makes sense to me. And then we can do a little cheat here and just say up direction gets false, or up direction gets true, because if the movement origin row is not smaller, if it's greater than the first movement row, that'll get covered by this else, and then we know it's an up direction. Then we can just worry about our if our movement origin column is smaller than our first movement column, then what? We know if our movement origin column, and column is the left and right, so if our movement origin is smaller than our first movement, then we know we locked in a rightwards direction. And then we do our same, we do our same trick here where we say otherwise left direction is true. So now only one of these should be true at any given moment. And so that's why it's good we actually put it in this mouse function, because this only gets called once we're in movement 3 and we're setting it to movement 4 right after we do it. So we shouldn't have any risk of having duplicate or multi-directional directions locked in. This is a perfect opportunity to use our second debug option. So we want to render top lock, meaning we moved upwards. I guess we'll say up lock, down lock, left, right lock. So here is our up locks, up direction. Now debug offset times 2. Now we need 3 of these. So we need 1, 2, 3, and we need down lock, left lock, right lock. Pass in corresponding variables. So we're testing for hopefully only one of these becomes true, and hopefully the correct one becomes true. So we will test each direction here and see if we are locking in our direction correctly. We're just crashing, so either I'm missing a else up here, which this seems fine. So maybe we typed something wrong down here. We just have 2 ends here for some reason. Okay, That should work. Okay, let's try a top lock. So right now, up lock should, or yeah, up, down, left, right lock. Okay, so let's test up lock. So we'll say we lock this in, and then our legal move is here. So up lock should be true. We also lock in a left lock there. Why would we lock in a left lock? This is why we need to test things, because I would have thought that we could only lock in one. And we're doing this based on our first movement row and our movement origin row. Okay. How is left lock true? It's because our movement origin column was actually greater than our first movement column. Oh, okay. So this gets triggered because our movement origin column is actually equal to our first movement column in this scenario, which does not constitute equality, so left direction gets called. So either we book this into one thing, or we fix this logic here when we could say greater than. I think let's just be explicit here. I think we'll go through and do everything explicitly, and we'll say all in else ifs, so we can't lock more than one. So we just do the opposite here. And then we continue with an else if that is this one, and then else if, and we just be explicit because our movement origin column would have to be bigger than our first movement column to be a left direction lock. And then now we should only have one locked in, and we've got if this. Okay. I think we're missing thens on all of that, actually, yeah. Okay. Okay, all false locks, right? Now, move type move, we lock it in. And then when we click on this, let's test up lock. Only up lock should be true, which it is. Now let's try left, lock it in, click it, left lock is true, and only left lock. If we do more clicking, it doesn't change it because we're in a movement 4. Let's try our down lock. That was my bad. Let's do a down lock. Down lock. We can click this, that's cool. Let's do a right lock and test. Right lock works. So one last thing I want to try is capstones, standing stones. Make sure we don't render those, and render lay stones can be a legal move, so these bottom or these right two ones should be able to be a legal move, which we'll test right now. We lock it in, legal move, no legal move, no legal move. If we click over there, it doesn't do anything. Yet if we click here, it locks in down lock, and it also locks in our first movement origin, or our first movement row, first movement column. So we'll actually put that in our debug 2 just so we can see it and verify. So This is going to be debug offset 6 and 7. So I'll go ahead and do that times 7, and we need this to be times 6 on this line. And then make sure we pass in, actually, I want to do this a little different. I actually want this to be 2, want this to be 3, and we'll actually put first movement, I'll say first movement row. First move row. And then first move column. And then the real 2, 3, 4 is actually going to be 2, 3, 4, 5 is actually going to be 4, 5, 6, and 7. Then if we want to stay neat about it, we can put it in its appropriate space, which is there. Okay, let's test it out. Okay, hold 2, lock it in, and then we're gonna lock in our, oh, look at this. Why is our first movement actually populated right now? This is totally wrong. First, oh man, I realized I did it. We added the debug text for our first movement row, but we are not populating it with the correct variable. So our first movement row here, first movement column here. Now it should work as expected. Lock it in, and up should be 2, 3. So 2 on the row, 3 on the column. 2, 3, up, lock, true. Cool. So we're now on movement event 4. So I think that wraps up movement event 3, if I'm not mistaken. And it looks like if we look at our legal moves at this point in time in our movement event 4, everything's false. Oh, it isn't false. We need to, our orthogonals are still true. So we actually need to falsify all legal occupants. What is it? Falsify all legal moves. We have a function here. Falsify all occupants legal move. We need to run this after, or right before we switch to a movement 4, sorry. Right before we switch to a movement 4. So right before we do that, we say, hey, falsify all our occupants legal moves. So we start with a clean slate, and then in movement 4 we can assign whatever legal move to our locked in direction, which should be right. So loop type move, click in a legal move, lock it in, debug 2. We're gonna say this should be same row, so 3, but column of 2. So it should be movement row 3, column 2, 3, 2, left lock, true. Now we're in a movement event 4, and I'm gonna hover around, make sure everything is false. Our orthogonals are now false. Everything is false as a clean slate for our movement event 4 logic. So next episode we're going to be adding, pressing down will drop stones into our first movement. Pressing up will pick up any stones we may have dropped into that first movement. And then pressing enter would lock that in, which would then become a movement 5, which would lock in. We've already got our direction locked, so we know that the next grid after that needs to be another left lock. So move it, 1 column less if it's not the edge of a grid. If it is the edge of the grid, we need to make the player drop all stones before anything would happen. So like we might need some, we'll have some move detection that we actually might need to, trying to think of how we prevent a person from I don't know. Because once we're at an edge, you know, we need to make sure we can't carry stones into a grid that would be off our main grid here. So we have to do some sort of checking upon a first movement locked that says, is this an edge? And if it is an edge, we have to drop all occupants when we press enter. Otherwise, we cannot shift to the next player. Like, we would have to shift to the next player, and that would mean we have to make the player drop all their stones and lock, and they can only lock in all stones dropped, because that's the only valid move they'd have left, is to dump all their stones there. So we need to make sure we ensure that. So let's see in our tech notes. So look, we're gonna say that we need to ensure all stones are dropped in first movement grid if that grid is an edge or corner case. Only if it's not an edge or corner case can we lock in the next direction based on our move lock. So we'll make sure to do that for next episode when we're working on our movement event 4. Is that right? Yeah, because we just finished movement event 3. Here's what all that code looks like. Wow. So look. Oh no, that was, here's some movement event 2. So our 3 is from here to here, which is a decent little chunk. But yeah, this is so much easier to maintain than our old system. And if we wanted to, it would be much easier expandable to our 6 grid board. But I'm not going to be doing that. It's just a bit much. But it feels good to refactor this stuff into something more maintainable, which is a good skill that I've been needing to practice. It's looking a lot more readable and a lot more maintainable. So I'm happy with that, and I will actually, we'll make our commit here. We take a look at our git diff real quick. We took out that update that rendered legal move highlights based on legal move status. We added legal move highlights for our movement event 3. And we added click detection to lock in our direction and our first movement grid. And then we've got some debugging to help us. So a nice little productive day we got. And we'll get add commit. Add everything to the staging area, commit with a message saying finished first draft of, I'm just gonna say finished movement event. Is that what we call it? Sounds wrong. Yeah, movement event 3. So yeah, we finished movement event 3. Finished movement event 3. Logic. Git push it. And then I will see you guys tomorrow for another episode. And then hopefully we can get movement event 4 settled tomorrow. Yeah, then we'll keep chugging along, and then we're in the home stretch. I mean, once we get once we finish our movement events, easier said than done. But once we finish those, we're in the home stretch of the game, because then we just need to worry about play state or win state and other tinier stuff that isn't as difficult as this logic. But we'll get there when we get there. See you tomorrow.